In 2007, a graduate student was digging through old telescope data when he found something that shouldn't exist. A burst of radio waves so powerful, so brief, and so distant that it challenged everything we knew about the universe. This is the story of fast radio bursts, one of astronomy's greatest unsolved mysteries. Hey everyone, welcome back to the channel. Today we're diving into one of the most perplexing phenomena in modern astronomy. If you're new here, we explore the biggest mysteries in space and science, so make sure to hit that subscribe button. Let's go back to 2001. The Parkes Radio Telescope in Australia was scanning the sky, collecting data on pulsars. Years later, Duncan Lorimer, along with his student David Narkovic, was analyzing this archived data when they spotted something extraordinary. A burst of radio energy that lasted just 5 milliseconds. 5/1000ths of a second. But in that tiny fraction of time, it released as much energy as the sun produces in an entire day. And it came from a galaxy nearly 3 billion light-years away. At first, the scientific community was skeptical. Was it interference? A satellite? Someone's microwave oven? Radio telescopes are notoriously sensitive, and false signals are common. Some astronomers even thought it might be a glitch in the data processing. But as more of these bursts were discovered, each from different parts of the sky, each billions of light-years away, it became clear these fast radio bursts, or FRBs, were real. So what exactly is a fast radio burst? Imagine the entire energy output of the sun for a whole day, compressed into a flash briefer than a human blink, and beamed across billions of light-years of space as radio waves. They're incredibly bright, incredibly brief, and incredibly mysterious. The radio frequencies typically range from about 400 to 1600 megahertz, similar to your FM radio, but much more powerful. And here's the kicker. For decades, we had no idea what caused them. For years, FRBs were maddeningly difficult to study. They appeared without warning, lasted milliseconds. And by the time astronomers could point other telescopes at their location, they were gone. It was like trying to study lightning by looking at the sky after the flash. Between 2007 and 2015, astronomers detected only about 24 FRBs. Each one was a one-off event, a single burst from a random point in space that never repeated. Or so we thought. Then in 2015, everything changed. Astronomers discovered FRB 121,102, and this one was different. It repeated. Over and over again, irregular bursts came from the exact same location in space. This was a game changer. For the first time, astronomers could study an FRB source continuously. They could point multiple telescopes at it and wait for the next burst. And what they found was even more puzzling. The repeating bursts allowed scientists to pinpoint the source with unprecedented accuracy. FRB 121,102 was coming from a dwarf galaxy about 3 billion light-years away. But more importantly, the bursts seemed to be coming from a region with an extremely strong magnetic field. This led to the magnetar hypothesis. Magnetars are neutron stars with magnetic fields 1,000 trillion times stronger than Earth's. They're the most magnetic objects in the universe, and they occasionally have starquakes, where their crust cracks and releases enormous bursts of energy. Could FRBs be coming from magnetars? It made sense. The energy levels matched. The magnetic fields were right. But there was still no direct proof. And then came April 28, 2020. Multiple telescopes detected a powerful radio burst from inside our own Milky Way galaxy, just 30,000 light-years away. This was FRB 200,428, and for the first time, an FRB was close enough to study in detail. The source? A magnetar called SGR 1935 plus 2154. Finally, we had our smoking gun. FRBs could definitely come from magnetars. But here's where it gets complicated. This burst was much weaker than the extragalactic FRBs we'd been detecting. If it had been billions of light-years away, we might not have detected it at all. This discovery raised a new question. Are all FRBs from magnetars? Or are there multiple types of cosmic events that can produce these bursts? Some FRBs repeat hundreds of times, others never repeat at all. Some come from regions with old stars, others from active star-forming galaxies. The mystery was deepening, not clearing up. Just when astronomers thought they were getting a handle on FRBs, something even stranger emerged. In 2020, researchers discovered that FRB 180,916, a repeating source, followed a pattern. It would burst for 4 days, then go silent for 12 days, then burst again for 4 days. Like clockwork, a 16-day cycle. What could cause such regularity? One theory involves a binary system, perhaps a magnetar orbiting another star, with the bursts only visible when the magnetar is facing us. But this is still speculation. Here's another oddity. FRBs show something called frequency dispersion. Lower radio frequencies arrive slightly later than higher frequencies. This happens because radio waves travel through the plasma in intergalactic space, and lower frequencies get delayed more. But the amount of dispersion tells us how much stuff the radio waves traveled through, which tells us how far away they are. And FRBs show enormous dispersion, confirming they come from billions of light years away. The universe itself is acting like a cosmic fingerprint analyzer. Perhaps the biggest mystery is the sheer energy involved. Some FRBs release as much energy in a millisecond as our sun produces in 80 years. How? Even magnetar starquakes struggle to explain the most powerful bursts. Some astronomers have proposed more exotic explanations: colliding neutron stars, evaporating black holes, even extraterrestrial civilizations using massive energy beams for space travel. While most scientists favor natural explanations, the truth is we still don't fully understand what's going on. Today, we're in the middle of an FRB gold rush. New telescopes like CHIME in Canada are detecting dozens of FRBs every month. As of 2024, we've cataloged over 1,000 of these bursts. Each one is a piece of the puzzle. We now know that FRBs are far more common than we thought. Perhaps thousands happen across the observable universe every single day. We were just missing them because we weren't looking in the right way. But FRBs aren't just cosmic curiosities. They're powerful scientific tools. Remember that frequency dispersion? It maps all the matter between us and the FRB source. This means FRBs can help us study the cosmic web, the large-scale structure of matter in the universe. They might also help us solve the missing baryon problem, the fact that we can't find about half the ordinary matter that should exist in the universe. FRBs could reveal where it's hiding. Despite all our progress, huge questions remain. Why do some FRBs repeat while others don't? Are there different classes of FRB sources? What's causing the most energetic bursts? Could some FRBs be caused by phenomena we haven't even imagined yet? And perhaps most intriguingly, the first FRB we detected happened in 2001, but we didn't recognize it until 2007. How many more were in old data, waiting to be found? What patterns might we have missed? Fast radio bursts remind us that the universe is still full of surprises. In just 2 decades, we've gone from complete ignorance to having hundreds of detections, yet the fundamental mystery remains. And that's what makes astronomy so exciting. What do you think is causing the most powerful FRBs? Let me know in the comments below. If you enjoyed this video, smash that like button and subscribe for more cosmic mysteries. Until next time, keep looking up.